Good morning, dear students. My name is Ferhan Mazher, and today is 12th of February 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O Levels Physics. And today we have set our hearts to solve a paper 2. We call it theory paper. Today we have selected October November 2021 2-1 paper. This paper belongs from the zone 1, or you can say it's variant 1. The section A of this paper I have already solved, and it has been uploaded in my YouTube channel. Today in this session, in this video, we are going to solve the section B of this paper. So let's hope for the best and let's start this paper. Section B. So today we are going to solve the section B of this paper. So it's starting from the question number 8. In the section B, we have question 8, 9, and 10. So he says a loudspeaker is made from a coil of wire fixed to a cardboard tube. The tube is attached to a cardboard cone. Figure 8.1 shows part of the arrangement of the loudspeaker. So you can see here we have the cardboard cone. Here we have the cardboard tube. On this we have this coil. When there is a current in the coil experiences a force. State what else is needed to a loudspeaker to produce a current carrying wire experience a force. So to this current carrying coil can experience a force if we put a permanent magnet here. If we put a magnet here, basically. So the answer here will be a magnet. So if you have ever seen any speaker, you will always find that we have a magnet at the back of the speaker. So a student connects the coil to the output of an alternating current AC generator. Figure 8.2 shows how the electromotive force EMF produced by the generator varies with the time. The coil tube and cone vibrate backwards and forwards. Explain why the EMF shown in the figure 8.2 makes the coil vibrate. Okay, so this is the current which you have provided to this coil, and you can see this current. If you look at this current carefully, let me show the graph. This is the EMF time graph of that current, and you can see that EMF is going up to 3. I think this is 3.6, and so it's being positive. Here it's positive. Here it's minus 3.6 volt. So the current you provided is alternating current. It's positive, it's negative, positive, negative. Alternating current means that the direction of the current is changing. And you can see that the time period of the current is 0.005. 0.005. Okay. So he says explain why the EMF shown in the figure 8.2 makes the coil vibrate. You see this coil. When you introduce current into it, this becomes an electromagnet. So this coil will have its north pole, its south pole, maybe the north here, maybe the south here. When the direction of the current will change, the polarity of this electromagnet will also change. So for example, if north was here, now here we will have south. So when the direction of the current flowing through this coil reverse, the polarity on this electromagnet also reverses, because there will be a permanent magnet here also. So with that permanent magnet, this electromagnet will be interacting. So it might be attracted and then it might be repelled. So if it was being attracted when the current has a certain direction, when the direction of the current will reverse, they will no more attract each other. The electromagnet and the magnet, they will no more attract each other. They will start repelling each other. So when the current direction will again change, it will start again attracting each other. So sometimes this coil will be attracted to that permanent magnet, and sometimes it will be repelled from the permanent magnet, because this coil is glued to this cardboard tube, and that whole assembly will be moved backward, forward, backward, forward, backward, forward. So this, due to this this cardboard cone, and that will also vibrate forward, backward. So it's a 2 marks question. Let me show you my written answer, and then we will go. That's the question number 8, I think. Yeah, 8, A part. So question number 8, A part, the magnet is the answer. Question number 8, B, first part, due to current in the coil becomes electromagnet. When direction of the current reverse in the coil, the polarity of the electromagnet changes. This electromagnet will be attracted to permanent magnet and then it will be repelled. So the coil will vibrate. So as the direction of the current will reverse, the polarity will reverse, the attraction might convert into repulsion. And when this thing happens periodically, so the cone will vibrate. Okay, so let's move to the next part. He says, the vibrating cone produces sound in the surrounding air. Explain in terms of the molecules how the cone produces a sound wave that travels through the air. You see, very simple. When the cone moves forward, it creates compression in the adjacent layer, and when the cone moves backward, and then it creates a rarefaction in the adjacent layer. And because the cone continues to vibrate, and so the continuously compressions and rarefactions are produced in the adjacent layers. So in the adjacent air, compressions, rarefactions are produced. This creates a longitudinal wave in the air. So that's how the sound is produced in the air. So let me show you my answer. I have written this answer. Okay, vibrating cone produced compression and rarefaction in adjacent layer of air. So the longitudinal waves are produced in air. Longitudinal waves travel in air. So this is how the sound will travel in the air. Okay, so he says the next part is, he says, sound is a longitudinal wave. Describe the difference between a longitudinal wave and a transverse wave. You see the longitudinal wave and the transverse waves. In the longitudinal waves, you know, the particle of the medium through which the air is traveling vibrate parallel to the direction of the wave. In the transverse wave, the particles of the medium vibrate perpendicular to the direction of the wave. The longitudinal wave consists of compressions and rarefactions, whereas the transverse waves, they consist of crust and trough. It's a 2 marks question. Let me show you my written answer. Okay, so here we go. In longitudinal wave, particles of the medium vibrate parallel to the direction of the wave, whereas in the transverse wave, they vibrate perpendicular to the direction of the wave. In longitudinal wave, compressions and rarefactions are present, whereas in the transverse wave, troughs and crust are present. Okay, so let's go to the next part. He says, using the figure 8.2, determine the number of times that the cone reverse its direction of motion in 1 second. You see, whenever a complete cycle, in one complete cycle, the cone will change its direction 2 times. In one complete vibration, the direction of the motion of the cone will be changed 2 times. Okay, so in 1 second, how many times the vibrations are, how many vibrations are completed? So because the time period here, you can see from here, I told you that the time period can be understood. To complete the one wave, you see, to complete the one wave, how much time is taken? 0.005 seconds. So let me show you how this is done. So because I know the time period, that's 0.005 seconds, I can find out the frequency. The formula for the frequency is 1 divided by time period. So 1 divided by 0.005, and that will be 200 hertz. So in 1 second, there will be 200 complete vibrations of the cone. So it means in one vibration, the direction of the motion is changed 2 times. So because in 1 second there are 200 vibrations, and in each vibration 2 times the direction is changed. So in 200 vibrations, 2 multiplied 200, 400 times in 1 minute, in 1 second, sorry, 400 times the direction of the motion will change. So that is the question. Let me show you. Done with this. 400 times is the answer. Okay. Then the question is the speed of the sound in the air is 340 meter per second. Calculate the wavelength of the sound. You know, we know that V is equals to F lambda. V equals to F lambda. We know that the V, that's 340 meter per second. We know the F, and we can find the lambda wavelength. Let me show you. It's a 2 marks numerical. Okay. So V is equals to F lambda. 340 meter per second is the speed. The frequency is 200 hertz. And lambda is question. So lambda will be 340 divided by 200. So it will be 340 divided by 200 is 1.7. So the wavelength is 1.7 meter. Okay. The student adjusts the generator so that the maximum voltage of the output is now 3 volt. Everything else stays the same as the output shown on the graph figure 8.2. Explain any effect on the loudness of the sound. You see, previously we read that from the figure that the voltage was 3.6 volt. Now they have reduced the voltage to 3 volts. So whenever you reduce the voltage, the amplitude of the vibration will decrease. If you decrease the voltage given to this loudspeaker, the amplitude of the vibration of its cone will decrease, and on the amplitude of vibration the loudness depends. So what will happen, the sound will be less loud, or you can say the sound will be fainter. Why? Because when you reduce the voltage, previously the voltage was 3.6 volt, now it's 3 volt, the amplitude of vibration decreases. So when the amplitude of vibration decreases, the loudness will become smaller, or you can say the sound will be fainter. In the second part, he says explain any effect on the pitch of the sound. You see, if you decrease the voltage, it has no effect on the time period of the wave. It has no effect on the time period of the vibration. It has no effect on the time period. It has no effect on the frequency. And you know the pitch depends upon the frequency. Higher the frequency, higher will be the pitch. Less the frequency, the lower will be the pitch. So because when you change the voltage, the time period do not change, the frequency do not change. So the pitch of the sound will remain unaffected. There will be no change in the pitch of the sound. So my dear students, we are done with the question number 8, and the question number 9 is now coming. So before we go to the next question, okay, so here on your screen, my dear students, the marking scheme of the question number 8 is showing up. You can pause the video and take your time and read this marking scheme carefully. It's very, very, very important to check your answers, to compare the answers you have given with the standard answers. So it's very important habit to compare the answers with the marking scheme issued by the Cambridge. So we are done with the marking scheme. Hopefully you have learned it from something from here. Question number 9, liquid in glass thermometers use the expansion of a liquid to indicate the temperature. Figure 9.1 shows the molecular structure of a solid and a gas. Okay. So here you have solid, here you have gas. The liquid structure has not been shown. In the middle box of the figure 9.1, sketch a diagram to show the molecular structure of a liquid. The molecules of the liquid, they are not arranged in regular patterns. They are randomly placed, and some of the molecules are close to each other, some are away from each other. So the molecules will be moving in all directions in random motion. So the intermolecular spaces will be larger than the solid molecules, but less than the air molecules. So let me show you my answer. I have written this answer. So question number These are the written answers for the question number 8C first part and the 8C second part. Okay, so this is the question number 9A first part. That's the diagram which I have drawn. You can draw the liquid molecules diagram from your textbook also. Okay, so let's move to the next part. He says, explain why it is easier to compress a gas than to compress a solid. You see, in the gas molecules, there are a lot of larger intermolecular spaces, and the repulsive force of the one atom with the other atom of the gas, or one molecule with the other molecule of the gas, the repulsive force is less in the gas as compared to the repulsive force present between the atom or the molecule of one molecule and the other molecule. So because there is less repulsive force, so you can apply the force and you can bring the molecules closer to each other in the case of the gas, because the repulsive force between the molecules is less strong. So it's a 2 marks question. Let me show you my written answer. So here we go. Okay. So gas molecules have larger intermolecular spacing as compared to solids, and the gas molecules have less repulsive forces between its molecules as compared to solids. So that's why it's easier for the gas to be compressed. Okay, so let's go to the next question. He says that the temperature of a liquid in glass thermometer increases. State 2 ways in which the molecules of a liquid in the thermometer are affected. So you see, you have increased the temperature of a liquid in glass thermometer increases. So the temperature has increased. So state 2 ways in which the molecules of a liquid in the thermometer are affected. When the temperature will rise, the molecules, they will move away from each other, and the spacing between them increase, and the molecules start moving faster. So when they move faster, they will have higher kinetic energy. So 2 things will happen. One, that the molecules will move away from each other. The second thing which will happen, the molecules will be moving at a faster speed, so their kinetic energy will be larger. So that's the third part. Let me show you my answer. And okay, so here we go. Molecules have higher speed and the molecules move away from each other. Okay, so let's go to the next question. The next question coming up on your screen is, okay, figure 9.2 shows the liquid in glass thermometer. There is no scale on the thermometer. State what is meant by the ice point and the steam point. Okay, so ice point is basically a point marked on the thermometer, and that point basically represents the level of the thread when the thermometer was in the melting ice. So wherever the thread of the mercury stops and becomes steady, its level becomes steady. At that position, we mark a point on the thermometer, and that point is known as ice point. Steam point basically means a point on the thermometer, or which means that it shows the level of the thread of the mercury when the thermometer is placed in the steam of the boiling water. So at that point, the level of the mercury becomes steady, and we put a mark on the thermometer, and we call it steam point. The ice point basically corresponds with the 0 degree centigrade temperature, and the steam points corresponds with the 100 degrees Celsius temperature. Okay, so let me show you the written answer. My written answer, here we go. Temperature, ice point. First of all, ice point. Temperature shown on thermometer, which it is in the melting ice. And temperature shown on thermometer when it is in the steam of the boiling water. Okay, so hopefully you can write a good answer of this question. Then he says, describe how the ice point and the steam point are used on the thermometer. You see, once you have marked the ice point and the steam point, Ice point you get by putting the thermometer in the melting ice. So wherever the level of the mercury becomes steady, at that point you put a mark on the thermometer and you write there 0 degree centigrade. And steam point, you put the thermometer in the steam of the boiling water. The level of the mercury rises when the level of the mercury becomes steady. At that position, you put a mark on the thermometer and you write there 100 degrees centigrade. Then you divide the distance between the ice point and the steam point into 100 equal intervals. So you can see this is being used to calibrate the thermometer. So let me show you my written answer, and here we go. Mark 0 degree centigrade on thermometer when thread of the mercury becomes steady, coinciding with the level of the thread when mercury thermometer is in the melting ice. Mark 100 degrees centigrade on thermometer coinciding with the level of the mercury thread when the level becomes steady in the steam of the boiling water. Interval between 0 degree centigrade and 100 degrees centigrade on the thermometer is divided into 100 equal parts. So this is how you use the steam point and the ice point to calibrate the thermometer. Explain how the range of a liquid in glass thermometer is affected by increasing the mass of the liquid in the bulb. You see, if you increase the mass of the liquid in the bulb, so what will happen? Larger mass of the liquid will have larger expansion for the same rise of the temperature. So because now the liquid will be expanding more, so at a smaller temperature, at a lower temperature, the liquid will expand so much that the liquid thread, the mercury thread or the liquid thread, will reach the end of the thermometer. So the range of the thermometer will decrease. So let me read my answer to you, and here we go. Range will decrease because larger mass of the liquid will have larger expansion. At lower temperature, thread of the liquid will reach the end of the thermometer. So the range will decrease. Okay, so the next part is this one. He says, increasing the diameter of the narrow tube. So what is the effect on the range? When you increase the diameter of the narrow tube in which the mercury travels or the liquid travels, if you increase the diameter of that tube, now the liquid will require a larger expansion to cover the length of the tube. So the range of the temperature which it can measure, that will increase because now larger expansion in the liquid will be required to cover the certain length of the thread. Okay, so let me show you my written answer. So here we go. Range will increase because in larger diameter of narrow tube, larger expansion is needed to cover the length of the tube. So the range will increase. So that was the question number 9C, second part, and I hope that I think that this is over. So the question number 9 is completed. So let me show you the marking scheme. So here we go. My dear students, the marking scheme of the question number 9 is showing up on your screen. So you can pause the video and take your time and read this marking scheme carefully. Okay, so pause this video and watch and read and compare your answers, my answers, your teacher's answers with this marking scheme. It is a very, very important fact. It's a very important habit to check the answers and compare them with the marking scheme. Normally, I tell my students, we never attempt any question whose marking scheme we don't have. The isotope yttrium-90, its proton number is 39 and its mass number is 90, nucleon number is 90, is radioactive. It is a beta particle emitter that decays to produce Q. So the parent, the daughter nucleus will be Q. Product Q is stable. State one feature that is common to all isotopes of the yttrium. All the isotopes of the yttrium will have the same proton numbers. So they all will have the same number of electrons in their orbit. So they will all have the same number of protons in their nuclei. All the isotopes. Then the B part is, he says, describe how a neutral atom of the Q differs from a neutral atom of the yttrium 90. So let me show you, because it emits a beta particle. So here we go. That's the answer for the first part. All isotopes of the yttrium will have the same number of protons in their nucleus. Okay, so the yttrium goes under the beta decay. So whenever a beta particle is given out, the daughter nucleus proton number is one more than the parent nucleus, and the nucleon number or the mass number do not change. So the Q4090 have 40 protons, 50 neutrons, and 40 electrons. And the yttrium 3990 have 39 protons, 41 neutrons, and 39 electrons. So here we go. So this is how you can write this answer. Hopefully you understand. It's a 3 marks question. He says, a sample of yttrium 90 is placed close to a radiation detector in a laboratory. There are no other radioactive samples in the laboratory. A counter records the count rate. Figure 10.1 is a graph of the count rates plotted against time. And you can say, using the figure 10.1, determine the average background count rate. Average background count rate we have to tell. So this is the graph. Let me increase the size so you can see. So here you see. So you can see here that when the graph becomes flat, the rate has not dropped beyond this. So what is this reading? What is this straight line reading? This is 18. So it means that the count rate is not dropping below that 18 reading. So it means that the background radiation is 18 basically. So let me show you. Here we go. So the average background count rate is 18. So this is the answer coming from the graph. This answer is coming from here. It's 18. He says, using the figure, oh yeah, this one is done. Okay, he says, suggest two different origins for the background count. You know, the background radiation, which is present always around us, there can be many reasons. One of the famous reason is the cosmic rays coming from the outer space onto the ground. That's the reason for the background radiation. Another reason can be there might be some rocks in your area which have minerals which are radioactive. And some other reasons can be that there might be some nuclear testing going on, or there might be some disposal. They might have disposed of the nuclear fuel in your area. So these can be the some reasons. Okay, you only have to mention here two. Let me show you my answer. Okay, so here you can see I have written cosmic rays and the rocks. Rocks in the soil, and the rocks might have some minerals which are radioactive. Okay, so figure 10.1, determine the half-life of the yttrium 90, show how the answer is obtained. Okay, so we have to find out. Okay, so when the time is 0, the count rate is 74. From this count rate, first of all, I will subtract the background. So 74 minus 18, that's 56. So when one half-life will pass by, the activity will be left half. So 56 divided by 2, so the count rate will become half. So, from the graph, you will have to add again the background, and you will get 56 divided by 2 plus 18, and you will get 46. So from the graph, I will tell you, let me show you from the graph, 46. So from the graph, I can show you what is the half-life. 46 will be here. This is that reading 46. So what I will check what's the value here. So this is the half-life. Okay, so from graph, I can say it is 65 hours. So from graph, I can say it is 65 hours. 46 will be here. And that is approximately 65. So our answer will be the half-life is 65 hours. Many of the points plotted in the figure 10.1 do not lie on the best fit line. Explain why. Very simple. Because the radiation is a random process. You cannot predict that which atom and at what time the atom will decay. That's why the count rate all the time is it's varying, it's changing, because the radiation is a random process. So it's a 2 marks question. Let me show you my answer. Okay. Radiation is a random process. No one can predict when and which atom will decay. So that's why the readings are not on the line of best fit. So we are going to the last part of this paper. He says, a beam of beta particles traveling in a vacuum enters the region between the two parallel metal plates. One plate is negatively charged and the other is positively charged. Figure 10.2 shows the arrangement. So the beta particles are going to enter. This shows the beta particles. They are going to enter this region where you have the positive plate, negative plate. So because the beta particles, they are negatively charged, so automatically they will be attracted to this positive plate. So when the beta particles enter here, they will be deflected towards the top of this page. On the figure 10.2 shows the path taken by the beta particles as they travel between the two particles. So enter here, remain a little bit straight, and then starts moving in the upward direction. So hopefully you understand. This is, you can see I have shown this red color line shows the beta particles. The beta particles are negatively charged. So obviously they will be attracted towards the top, towards this upper plate, which is positively charged. So my dear students, today we are done with this paper. And today, my dear students, we have completed October-November 2021 Physics 5054 to 1 paper. In this video, in this session, we have done the section B of this paper. The section A of this paper I have already done, and it's uploaded in my YouTube channel. I have done my best to solve question number 8, 9, and 10, and I have tried to explain the concepts which were involved and the procedures and the statements. And I want to specially thanks to my students who are helping me to make these slides and to write these answers. Special thanks to my student Fatma Zia, Mina Kium, Miral, and Taiba and Zainab Farouk for helping me to prepare these papers. And special thanks to Manur Bashir also. So thank you very much, everybody. It's a blessing for me to be helpful to you. I hope that this video will help you to do this paper by sitting at your home and by just watching this YouTube video. So if you think that this video is helpful and it's helping you, and it can also help you, your friends, your class fellows, your juniors, your seniors, please do share the link of this video onto your Facebook account and onto your Twitter accounts and into your Instagram. I also like my video and also subscribe on my channels. So thank you very much, everybody. Have a good day and God bless you all.